This video, we're going to prove the following fact. If phi of n divides n minus 1, then n is a square free number. That is, in the prime factorization of n, all the powers are 1. None of them are 2 or more. Now, I'm not so sure that I know how to do this one directly, so how about we look at the contrapositive? If this, then that. But the contrapositive, if you think about it, it says if the conclusion is false, then the premise is false. Okay, so what I'm going to prove instead is I will prove that if n is not a square free number, then phi of n does not divide n minus 1. If you like watching mathematical proofs like this, you should consider subscribing to my channel. So, if n is not a square free number, suppose that the power of P1 is at least 2. It's at least 2. So then what we have is that n is P1 to the K1. That's in n. P2 to the K2 all the way up to our PR to the KR. Now, phi of n is equal to P1 to the K1 minus P1 to the K1 minus 1 times P2 to the K2 minus P2 to the K2 minus 1. All the way up to PR to the KR minus PR to the KR minus 1. Now, the power of P sub 1, K1, it is at least 2. That means K1 minus 1 is at least 1. Now, if I pull out a P, in fact, that even means that K1 minus 2 is not negative. If I pull out it, the power is not negative. It can be 0, and P1 to the 0 is 1. So if I pull out a P, P1, I get P1 to the K1 minus 1. That power is at least 1, making this an integer, minus, I pull out a P1 from this term, and I get P1 to the K1 minus 2. And that also is 0 or more, making this an integer. This is P1 times an integer, times P2, K2, minus P2, K2 minus 1. These are all integers. Because, I wouldn't put P to the 0, because that's 1. All these exponents, all of these exponents are at least 1. This one, on the other hand, was at least 2. Okay, that's why I was able to pull out P1 and have an integer being multiplied by it. this is an integer minus an integer. The last one is an integer minus an integer. Okay, so this implies that P1 divides Q of n, because Q of n, there it is a multiple of P1. It's P1 times all of that. So this is true. Now,